everyone. Thanks for joining today's session. I'm excited to welcome Ori to talk a little bit about secrets management within kind of DevOps environments. So, when we talk about DevOps and DevSecOps, one of the critical pieces of that is secrets management. And how do you make those accessible to your processes, but also keep them secure and not floating everywhere around. So, really excited to welcome Ori, and I'll hand it off to you.
Thank you very much, Don. Happy to be here. Thank you. My name is Ori Mankali. I'm the VP of R&D here at Achilles. I've been here in Achilles for the last 3 years, and today's talk, I'm going to talk about a very painful issue that I'm sure that many of you can correlate to, is how can you manage a secure DevOps and production environment? And security has a lot of interpretations, I would say. We'll touch on specific points that are probably the most significant ones. And I'll be very practical today because I'm going to talk about how this can be implemented end-to-end in your environment. With that, let's cover today's agenda. So just to make sure that we're all on the same page, I'm going to describe what are secrets, even though this term is probably very common, especially when it comes to DevOps and DevSecOps environments. There are other definitions and different definitions, and we'll focus on that. Secondly, we'll discuss about I would say the last decade's trend of using more cloud-native technologies and the migration to the clouds, etc., that made an existing problem much more severe. I'll talk about a very common solution to managing secrets when using static credentials and what's wrong with that approach and why is it less secure. And then we'll switch to talk about potential solutions in the form of a secret management platform, and give you a few productive and technical examples on how to implement that using just-in-time access to achieve zero standing privileges in your production environment. And again, as I promised, to be more concrete, I'm going to talk about 4 different use cases that I'm sure all of you can correlate to. This is part of the traditional software development life cycle, or SDLC. And each one of them embeds a different approach to manage secure access and use secure credentials in different environments. The very last part, we'll probably talk about the summary and our understanding and how we can conclude that and move forward to implementing that. Before I get started, I just wanted to say a few words about Achilles, which is the company I work for. Achilles is essentially an enterprise-grade vendor for secrets orchestration. We have built a platform, a SaaS platform, which is both multi-region and multi-cloud. We're running on multiple cloud providers to ensure the highest level of availability and scalability in the highest standards you can think of. You can see a list of partners and customers that are public on our website as well, and certifications that we received in the last years, along with Gartner reports that mentioned Achilles by name. We're a global company, and the R&D center is in Tel Aviv, Israel. So what are secrets? Secrets can be anything that allows an application or a human to authenticate to a remote system. Very common example is a simple username and password that I use to log into, I don't know, to my bank account, to my Jenkins server, or whatever that requires this kind of authentication. It can be an SSH key that I'm using in order to connect to a remote SSH server. It can be a client-side certificate, API token, and the list is very, very long and diverse. Important to say that some of the secrets, or most of them, are used by applications. It can be a homegrown application. It can be a DevOps tool that I'm using in order to perform an automated job, for example, CI/CD, or a configuration management tool, or orchestration, a container orchestration tool, etc. There are different types of secrets, and we distinguish between them. The most basic one is a static secret, which means that anytime that you request this secret, or you want to retrieve it from an external store, you will get the same value over and over again. Like if I'm requesting my username and password, I can get them one time after another, and then I can use them to authenticate to my database. The problem with static secrets, we'll touch on just a bit, that if somebody's somehow exposed to this static secret, then they can simply bypass the secret store and just use whatever it's cached or stored in an insecure place. A rotated secret is somewhat similar to a static secret, aside from the fact that once in a while, in a predefined frequency, the secret or the password or the token, whatever it may be, it's being rotated and modified to a new version. And this is much more secure than a static secret, in the sense that there is a time window in which this secret will be valid, okay? And dynamic secret is just taking it one step further, which means that at a steady state, you don't have any kind of credentials, and anytime that application or a human would like to connect to a third-party target, we are able to generate those credentials on the fly, just in time, right? So we can generate a temporary username and password to a database according to a permission profile. We can generate a token that allows you to connect to your cloud service provider. We are able to create any kinds of credentials to different kinds of systems, and I'll elaborate on that even further down the presentation. Another interesting distinction is between the longevity of a secret. It can be a long-standing secret, like a static one, or it can be ephemeral, something that lives for a very short period of time, and after this period of time, it's simply being deleted from the remote platform. Yeah, so let's talk about the magnitude of the problem. Okay, let's start from the past. I'd say a decade ago, maybe 2 decades ago, it was very uncommon for organizations to run in a cloud-native environment. Most of them were using traditional monoliths running on server, physical bare metal hosts, maybe on an on-premise data center. They were running applications there, services, but those services were running for a very long period of time. Now, if we look at an application, this application most likely would need some kind of access to secrets. One example that's come to mind is, again, the database example. If this is a backend application, I would need to connect to the database and have different kind of permissions, one for writing data to the database, another one for retrieving data. If we're talking about CI/CD platforms, I would say that the old ones are probably Jenkins or something similar to that. Then the same thing, you would need access to some kind of a code repository. This access was probably based on credentials that were stored as a configuration file or environment variables, but they were very easy to grab. Okay, if you logged into this environment, to this host, you can browse the file system, you can search for environment variables if you have the permissions to do that. You can even dump the memory of some applications to see a lot of data, a lot of sensitive information and secrets. The transition to the cloud converted traditional monoliths to a lot of microservices in different environments, in a shared environment, in a multi-tenant environment, and a lot of DevOps toolchain, things that maybe until a few years ago were not very common, container orchestration platforms, CI/CD platforms, that are more modern, et cetera, and then you have, instead of a one server, you have thousands of services running on hundreds of different hosts. And all of them are interconnecting, all of them are using secrets. Now, a lot of the DevOps toolchain, a lot of the environments have came up with a solution to that. So they have their own local secret stores, for example, in Kubernetes and in configuration management tools, and even in CI/CD platforms, and then makes a lot of secrets being sprawled in different environments. Okay, so each one, each system, each tool, each application is managing secrets in a different way. not as a centralized solution. And moreover, some of them are using less common practices when it comes to security. One example that comes to mind that, for example, Kubernetes secrets are not encrypting the secrets by default. They're stored as base64 encoded strings in etcd, for example, by default. And again, the problem is not hidden from a lot of attackers and misuse. Some of them are intentional, like hackers trying to hack into a customer's environment or a production environment. Some of them are misused, or maybe by accident, when credentials are being leaked. If you take a repository that stores the configuration files or any kind of sensitive information in plain text, and then the visibility of this repository is changing by accident from private to public, and all of a sudden you get yourself keys and token being exposed to the world, right? So this is a very known problem, and I think that it's not going away. On the contrary, in the next years, I'm expecting to see more and more incidents of that nature simply because of the growth. A lot of companies are migrating to the cloud. Accidents will happen because we are human and we make mistakes. So the best thing that we can do is to minimize the chance of this being happen simply by not storing any kind of credentials, tokens, API keys, and any secrets in a plain text mode when it's insecure. Interesting fact that a lot of the breaches of organizations come from misuse of privileged credentials. This is coming from Forrester. And that's a very interesting insight. So it means that if you manage correctly privileged credentials, you can reduce a significant portion of the breaches all over the world. And that's exactly what we're aiming to do. We want you and other people to be able to facilitate it in an easy to use, a simple and secure fashion. When I say easy to use, I'm also referring to the operational hassle of managing such a solution, right? So let's look at this cloud right now with the logo Achilles, but it doesn't matter, because if we look at it as a centralized secret storage, few aspects that you need to take into account are the availability of that centralized system, right? Because if this goes down and all the applications, all the humans, or anybody that consumes secrets anywhere will try to retrieve any of the values, then they will not be able to perform their operation as intended. So this means that this is going to be a very significant business critical system inside the organization. So availability and scalability are something that needs to be taken care of. Being a SaaS platform, that's one of the benefits. We take care of those aspects for the customers. So they can rest assured that the platform would be managed in the highest standards in the industry to make sure it's highly available and serving whatever customers and clients and applications that are using that. This illustration here is showing a high-level diagram on the architecture. So in here we see some kind of an application, it doesn't matter which one, that can communicate with either a third-party service, a database, or even another instance of the same or another application. For this kind of communication, they need different kinds of credentials, API tokens, SQL credentials, TLS certificates, etc., etc. And this application needs access to that at runtime, so while this application is running. So what we see here is basically an integration. It can be an SDK or a RESTful API or a CLI or plugin, it doesn't matter, but some kind of interface that allows this application, based on trusted identity, to be authenticated and authorized to the centralized secrets management platform in order to retrieve an encrypted secret, either a static secret, a temporary or just-in-time secret, or a rotated secret. And as you can see, this secret is coming to the application while it's encrypted at the application level. So this application, in turn, will be able to decrypt it using a key that this application is the only one authorized to use it. And then this value over here is being decrypted at the application level, and then can be used to perform the interaction with the third-party service, the database, or the other application. Okay? Important to stress that this value is not stored locally, not on the file system, not an environment variable, but at the application level. Same goes for DevOps tools, right? If we're talking about a CI/CD platform, then using one of our plugins, the CI/CD platform will consume one of the secrets and extract it to use it as part of the, let's say, pipeline or job or whatever automated process there is for this tool. All right, so let's focus a little bit about the secrets management solution and how this can be made much easier. One significant value is the control and visibility of secrets. If you remember the diagram at the beginning, you saw a lot of different tools, a lot of different components in different environments, with different network access even. And all of them were managing inside of small silos, secrets with different permission set, with different policy of access, and with very little visibility to the activity. When you have a centralized system, it's very easy to display a detailed audit log of all the activities from all the environments that shows access to different secrets. And this can be forwarded to existing log and SIEM systems for ease of use and search and even managing the retention policy, if you will. This centralized system is serving two types of access, both by humans. One example is using a web UI, a very comprehensive and easy to use web interface, or by an application. Application can use either RESTful API, SDK, or even CLI if you're running a small automated script or a job, if you will. And this, along with combined with just-in-time credentials or dynamic credentials, can get you to a state where you don't have any standing privileges, meaning persistent privileges on the remote servers or targets. It means that if you look at the steady state, if nobody is connected to the database, if nobody's querying a database, there will be no users configured there. If nobody is connecting to a Kubernetes cluster, you will not have any kind of access by a random person. And this model can be very secure because for hackers, if there is no way of logging into the remote server, then they would have to find other ways to do that. One thing that we support, but I think that the goal of organizations should be removing that, is to use static credentials. The problem with static credentials, first of all, that there are too many privileges assigned with those credentials over time. Imagine one case that I'm onboarding to an organization, and on the first week, I'm probably being assigned with a default set of permissions. And over time, based on my need, I will need access to different servers with different permission sets to do a specific job or maintenance work or whatever. Then there is an exception process that allows me to request additional permissions and so on. And then over time, if they're not properly managed, those credentials will not be revoked, which means that my privilege is going to be extended over time if not properly managed. Add to that the fact that humans don't like to change passwords, because then we need to remember the new version, and I need to make sure that it's according to a specific policy. And I just want to log into my server, so the most easy thing to do is just to remember the last password I was using. So the password rotation frequency is very low, if any. Give it enough time, it will leak by accident or by, I don't know, some user or a hacker just browse my laptop if I left it open, or if I mistakenly sent a message in one of the channels or an email, or even if I committed a code change to a repo inside the organization. Eventually, if the password or the credentials will be lasting forever, it's just a matter of time until somebody, unauthorized person, will gain access to it. And then the story begins that once some unauthorized person have access to the credentials, they can escalate that in order to access the database, extract the data there, and search for other types of secrets and other types of credentials. And this is what we call essentially the lateral movement. You start small access to unauthorized credentials, and then you expand it over time to find more and more sensitive secrets, and then access more and more systems. Okay. You can easily eliminate that by using just-in-time access. Meaning, it's okay to have exception cases where you want to connect to a database in an administrative mode, or if you want to connect to the cloud service provider to perform some privileged task or whatever, but it has to be for a very specific purpose. It has to be for a very limited time to be just sufficient to do whatever you were planning to do. And it has to be audited. So you have visibility of who accessed this environment, who requested the secret. If it makes sense, this can be retrospected if there is some kind of an incident. And the most important thing, that at a steady state, you will not have access to those credentials. So in this illustration here, what we see here is that we have some kind of a database, a SQL database, which we want to have access to. Then we request just-in-time credentials from the secret management platform, and the customer application retrieves that for a very limited time and use those temporary credentials to connect to the database. After a predefined TTL, which is defined by the administrator, the credentials will be expired without any questions or restrictions. And this would make sure that after this time, nobody else can use those credentials. Now, in special cases, like when it comes to human, you can request to extend the TTL, but this has to be explicit. Okay, so you need to trigger an API call or to request from an administrator to extend the TTL. And this is also limited by time, so it wouldn't be forever. The use cases that are relevant to this story is, first of all, connecting to code repos. For example, if I'm using today, I don't know, GitHub or GitLab or any other code repository, I would need to be authorized to access private repositories. This can be done based on short-lived personal access tokens to allow you access to code repos on a need basis. Secondly, when you commit changes to your code repos, then you want to trigger some kind of a CI pipeline, and this CI pipeline may require access to other types of secrets. Thirdly, after the CI pipeline is running, most likely you would like to build and deploy artifacts to different environments, right? And this needs to be stored on some kind of a registry or a storage device of different kinds. And in order to authenticate to that repo, you would also need access to credentials. And last but not least, you also want to review that by a security administrator to see that all the operations were authorized and used by the proper applications or proper humans in the organization.
All right, so let me share with you the demo environment that I've set up for this purpose. It's somewhat like simulating a production environment in the sense that it contains a Kubernetes cluster running some kind of an application, and I'm using GitLab as my CI/CD platform and Docker Hub to store the Docker container which I'm building, and I'm also using my demo Achilles account. I'm showing right now what you're seeing is the console web UI, which is one of the interfaces that our platform supports. Obviously, everything that I'm doing here can be done programmatically. It can be done using the command line interface. It can be done using different SDKs, RESTful API, plugining, etc. But I'm going to show that from the web UI because it's easier to explain and demonstrate. So I have two types of dynamic secrets. Essentially, those allow me to connect using temporary credentials, ephemeral credentials to different resources. In this particular case, I'm using a dynamic secret to Docker Hub, which generates for me a personal access token that has both read and write permissions. When the token is being generated, it's valid for 10 minutes. And afterwards, it can be revoked. So if I'm clicking get dynamic secret, right now I'm getting this token. It's valid for the next 10 minutes, as I mentioned, but I can also click on this part as an administrator and see the user that requested it, and I can extend it and revoke it if I want to, and this will make sure that the personal access token no longer exists on Docker Hub. Same thing can be done for my EKS cluster, so I can get a temporary access token to it. And this will allow me to connect to the cluster. I also have a cert issuer that I'm using to connect to SSH resources, and just a dummy secret, a static secret that I'm fetching as part of my CI/CD pipeline. This can be anything from any kind of credentials, keys, etc., anything that you need. All right, so my IDE, by the way, the IDE that I'm going to use in this particular case would be VS Code, and I'm going to use a plugin that allows me to connect using SSH to a remote repository. It's a public plugin, and it's called Remote SSH. And what I just did is connected this plugin with Achilles, in the sense that instead of using the traditional SSH keys, which forced me to maintain and manage public keys on the server side. Instead of that, I'm using Achilles to issue an SSH certificate. And this is what allows me to connect to the remote host. The main benefit of that is that you don't need to manage those keys, as I mentioned, and then you can integrate this request of issuing the certificate with any kind of authentication method. In my particular case, I connected it to a SAML auth method with my demo Okta account. Okta illustrates the IDP, but it can be connected to any type of identity provider. When I'm clicking on this remote host, so I'm expecting, here it's connected, I'm expecting my browser to pop up any minute now. Yeah. And ask me to authenticate. And after successful authentication, you will see the session being established, and I will be able to browse the file system of the remote host, like you see in this case. And again, the main advantage is that I don't have a local copy of this repo on my laptop. If it contains sensitive proprietary code or any kind of sensitive information, then it's not on a local file system. So in this case, I only have a small project that I created. Some of it contains some scripts. Some of it contains some Python code that illustrates an application, a web application. The scripts that I'm using are build, deploy, and test. Again, illustrating the classic SDLC, where I merge some changes into the code repo, then I'm triggering some tests, building the artifacts and deploying them to the production environment. The code I'm going to show is a small Python code that builds a small web service, and it's running on Kubernetes. So I'm going to switch here. This is the web application that I'm currently working on. Just a showing a demo and showing the connection from, in this case, it's the load balancer. And this is a sad face of a small friend here. And it's also not playing. Maybe that's one of the reasons that it's sad. And I'm going to connect using another product that we have, the Achilles Secure Remote Access, to my EKS cluster. This allows me to be single sign-on to different kinds of applications. In this particular case, I can show the deployment. So it's something like this one. And you can see it's the deployment was last deployed in an hour ago. Now we have the application, we have this set guy, and we have the code repo. So let me illustrate like I'm modifying or fixing something in my environment. So in that case, it would be something like that. I can commit these code changes. I can go, I don't know, fix bug or whatever. And then syncing the repo. And then pushing the changes into the code repo. According to my configuration, when I push the changes to the repo, the pipeline is automatically triggered. So if I refresh this page, you can see that I have a new job with the commit that I just pushed to the repo. So if I'm going to the pipeline once again, then I'm seeing that it's progressing. As I mentioned, I'm using JOT as an authentication method. The reason I'm using that is because when accessing Achilles, I don't want to provide any kind of secret zero or initial API key or a token to authenticate to the platform. So I'm utilizing the JOT in order to authenticate to Achilles. And later on, I can see that in the audit logs, the activity. So we're seeing the image right now is being built. And we'll give it a few more seconds. Meanwhile, I'll show you my Docker Hub account. So I have this repo that contains the Docker image for the web application. Another thing that's worth mentioning that if I take a look at my account settings and under security, I can see all the outstanding temporary tokens that I have. This one was just created a minute ago, as you can see. And it's used to push the Docker image to the registry. So if I'm going back to visit my registry and seeing so I'm seeing that the image was just pushed. This gives me an indication that the process was completed. And what we are also seeing here is the deploy part, which means that after the artifact was deployed to the Docker Hub registry, then we're essentially restarting the deployment on the Kubernetes environment, the EKS environment, using Achilles Secure Remote Access solution. And if I'm going back to my cluster, I can see, so I can see that the new pod is being launched. And while it will be launched, the old one will be terminated. So it will take a few seconds. Meanwhile, I can visit the application. It's still showing the same thing. Give it a few more seconds to be deployed. So a lot of things are happening. We're using Achilles in different ways. We're using the authentication from GitLab. We're using dynamic secrets to create access to Docker Hub. We're using Achilles to connect to the EKS cluster, right? So we see that the new pod is already running. So I can go back to this page and simply refresh the page to see that this guy is happier now and playing nicely. And all that ecosystem, starting from the code to CI/CD, to the registry, to the deployment to production, is done in a secure fashion. There are no standing credentials, not in the code. not in configuration files, not in the CI/CD pipeline, and not anywhere in my production environment. That's kind of in a nutshell. Again, more than happy to expand on that on a side channel. So feel free to reach out to me for any questions or demos that you would like to see. Let's switch to talk about the key takeaways from this demo.
First of all, you want to always maintain the principle of least privilege, which means that whenever you generate just-in-time credentials, whenever you configure that, you want to minimize that to the very least required privilege to perform this operation. It's okay to have multiple types of secrets for different purposes, one for read-only, one for read-write, one for a specific policy, etc., as long as you use the proper ones for each tasks. When creating the profiles, you want to make sure to review them, revisit them on a regular basis, and making sure that they are still appropriate to the need at the time of the review. Secondly, don't expand the duration of those credentials for more than required. You want to minimize the windows of opportunities for a malicious user, and this can be done by minimizing the TTL to the minimum required. And you can always trigger a revoke operation once you finished performing what you had to do. And thirdly, using a centralized secrets management solution will minimize the secret sprawl and simplify the developer workflows in the sense that they will have only a single interface, a single API, a single way of managing and accessing the secrets across the organization. With that, I'd like to thank you for the time, for listening. And if you have any questions, you can reach out to me at ori@achilles.io. We'll be more than happy to have a follow-up conversation on any of the topics that I've discussed today. So thanks again, and see you soon.